Hello and welcome. I'm making this Stats 1 video because a big question I often get in my in-person class when we first start is, what is statistics? Where are we going with this course? What exactly are we learning? Well, obviously I can't completely answer that question right now because it involves material that we haven't covered yet. But I do want to show you just quickly, give you an idea of what the end game is here, so to speak. I'm going to be working with a data set here. This happens to be recording artists and number of albums released in albums sold in millions. And for the sake of this example, this is actually data that's in your book on the CD. But for the sake of example, I have 239 artists listed here. I'm going to assume that, for the sake of this example, that this is the population, that there, in all of existence, there are 239 recording artists. You know, that's obviously unrealistic, but we're going to go with that. So, if we look at statistics, we have two types of statistics. The first kind that we're going to be going over for most of the course is descriptive statistics, and that is just describing data. What's the mean, what's the median, what's the mode, etc. And then after that, there's inferential statistics. And that's, well, I'll discuss that in a little bit. That's where we try to make, we try to make inferences about a population based on only a small part of the population or a sample. So right now we have a population of recording artists. I believe it was a population of 239. And eventually what we're going to do is we're going to draw samples from that data. You talked about sampling techniques. You're reading about sampling techniques in Chapter 1, things like simple random sampling, stratified, etc. So let's describe this population. Well, there's 239 of them, and the mean or the average, you'll talk about mean and median in Chapter 3. The capital N we use for population size. This is the symbol for the mean or average of a population. And let's figure out what that is. And so I'm just going to use Minitab here. I'm going to go through this kind of quickly. I'm not going, making this a Minitab lesson here. I just want to get the mean and the median of this data. And so don't worry, well, standard deviation is a measure of the spread of your data. You'll read about that in Chapter 3. The mean and median you've probably heard of. I'm just going to worry about the mean for now, 25.9. So that 25.9 million albums, and that's for all 239 recording artists. Now, in a real-life situation, obviously, there are hundreds, thousands, millions of recording artists, and you don't have access to all your data. But what we can do, part of descriptive statistics, is we can draw samples from that data. So we could take one sample, we could take another sample, we could take another sample. Take 4 samples. So these are going to be samples that are drawn from that population. And I'm going to let, for each of these samples, let's say, I'm going to make a lowercase n because that's the size of our sample. So let's say 20. So I'm going to pick 20 artists at random from that population, and I'm going to measure their mean. And I'm going to symbolize mean with an X with a bar over it. Again, you'll see all this in more detail in Chapter 3, including how to compute all these things. I'm not going into that yet. I'm just computing them all with Minitab. So let's go back and select 4 samples. And I think I actually have to do this one at a time. Alright, so I have this set number of rows to sample, and go ahead and do that. And I'm going to do this 5 more times. So I'll be right back. I'll just do this a few more times. Okay, we're back, and we have the 4 samples of data from our population. This is like one of those cooking shows where they put something in the oven and they take out the finished product. Well, I didn't want to take up too much time in the video actually getting these columns, but anyway, so I should point out these no longer. This is not number of albums by Aerosmith. This is one sample, a random sample from the population. 2, 3, 4. So basically, we took sets of 20. We picked just at random of all these. We picked a set of 20, another set of 20, another, and another. So earlier, I got statistics, population statistics from that population. Now I'm going to do the same thing again, except I'm not going to focus on the population here. I'm going to focus on our 4 samples. And okay, and here we are. Here are the results of those 4 samples. So I have to copy these over. 2253, 2162, 2082, 2378. 2082, 2378. Okay, so you notice that the population mean is 29.9 million, and these samples 22, 21, 20, 23. Now, all these happen to be smaller than 25.9, which it can happen. Maybe just for fun I'll take one more. $26.75. Pulling the pen the wrong way. We fit another one here. 26.75. So you can see that the point I'm trying to make is that these means are different. And because I'm picking samples of 20, we don't have the entire population here. But what we instead have, we have to pick samples. Now, in real life, you're not going to have this population. You're going to have this, and you're going to have to make inferences. You're going to have to make inferences about the population given those samples. That's where the inferential statistics comes in. I have 21.62 in my sample mean. I have to infer what this is, what the population mean is. So you'll find out how to do that in chapters 8 and 9. So I won't get into that here, how it's done. But what you're going to eventually, so the inferential statistics is drawing, well, you're not going to draw 5 samples. You're only going to draw 1 sample. But the point is, you're going to take sample information. Notice the arrows are going in the other direction. You're going to take sample information and make inferences about the population mean. That, not just the mean, of course. We could do other statistics as well. And that's the basic goal of this course, is, you're going to start out with descriptive statistics. Chapter 1, again, preliminaries. Chapter 2, you're graphing data. Chapter 3, you're computing these numbers. Chapter 4, you'll talk about probability. Chapter 5 and 6, you're going to talk about ways that data can be distributed. Just real quick here, I'll show a histogram of this data, and you can see, although you won't cover histograms until Chapter 2, hopefully some of you have started that already, you can see that there's very few recording artists that are very, very successful. Most of them are more mainstream, lower album sales. This is an example of distribution of data. It's what we call a right skewed distribution, because you have a lot of unusually high data points to the right. Who's to say what's unusual? But anyway, you have a lot of data points. You have very high number data points. We call that right skewed. So that's a distribution of data. That's chapters 5 and 6. In chapter 7, you look at kind of the anatomy of samples, and how samples behave. And then finally, in chapters 8 and 9, you'll be able to do stuff like this. And one more final note, because you're going to see this term a lot in statistics, stats 1, stats 2. There's a name we have for the fact that these data don't have the same mean as the population. And that term is called sampling error. And I want to just go, this basically refers, I didn't mean to cross that out, but anyway, this refers to the fact that we get representative samples, but no matter what, our sample is not going to perfectly equal the population. I say error because there are differences between these numbers and this number. Error, when you see the term error, the word error in statistics, it doesn't mean mistake per se. What error means is that it's the result of, error is what happens when your sample doesn't perfectly match your population, which of course will be the case almost all of the time. Okay, I hope this clears up a little bit of where we're going and what we're talking about, samples, and where we're going with this. So I hope to make, like I said, I hope this helps, and enjoy the rest of the course.